So many theories made by the late Stephen Hawking. The James Webb Telescope has finally proved him right. Professor Stephen Hawking may have passed away before the James Webb Space Telescope was ever launched. Nevertheless, the new space telescope will spend a lot of time verifying some of the late physicist theories because of his extensive space legacy. Some of his theories are the dark matter theory and the multiverse theory, which is the very last theory that Stephen Hawking worked on before his passing. So join us today as we discuss how the James Webb Telescope finally proved Stephen Hawking's theory. What is James Webb Space Telescope, or JWST? The James Webb Space Telescope was launched 3 years after the death of Stephen Hawking in 2018. Due to several delays, the launch date was also postponed back in 2007 to 2011 and was also further shifted to a later date, approximately 10 times the initial budget. It also gobbled down $10 billion. This robust space telescope will first need to go through several months of calibration and testing after a successful launch and deployment of its parts owing to the substantial 6.5-meter big mirror that needed to be folded during launch. As an infrared telescope, the JWST looks for objects in space by detecting infrared light. It can see astronomical objects like planets, nebulae, and stars that are too dim or too cool to be seen with the naked eye in visible light. Despite seeming opaque to the human eye, gas and dust may be penetrated by infrared light, according to NASA. In contrast, the Hubble telescope, which is well known worldwide, only observes near-infrared and ultraviolet light. Numerous astronomers are competing for time with JWST. Due to the telescope's potential, astronomers were invited to submit proposals on how they would like to use James Webb, with 6,000 hours of observation time up for grabs by the Space Telescope Science Institute, which manages science operations on Hubble and JWST. The initiatives of the fortunate ones have now been approved, and we eagerly await the wealth of information they will impart to us. The amount of fuel aboard the Space Telescope ensures that the JWST will operate for around 20 years, giving it plenty of time to reveal the deep secrets of the cosmos. The telescope will also enable observers to look inside the atmospheres of planets outside our solar system. It is possible to observe the formation of new stars and planetary systems by peeping through enormous dust clouds. Light from the early universe will be able to be collected and reflected by JWST. JWST will be able to see light from the first stars and galaxies close to the Big Bang, which are estimated to be 13.8 billion years old. How JWST will prove Stephen Hawking's theory about dark matter. One of Stephen Hawking's most contentious theories may soon be put to the test. According to a new study, Hawking postulated in the 1970s that black holes created in the first seconds of the Big Bang might make up dark matter, the invisible substance that accounts for the majority of everything in the universe. 3 astronomers have now created a theory that explains both the appearance of the greatest black holes in the cosmos as well as the presence of dark matter. In a statement, study co-author and Yale University astrophysicist Priyambada Natarajan said, "What I find personally super exciting about this idea is how it elegantly unifies the 2 challenging problems that I work on, that of probing the nature of dark matter and the formation and growth of black holes, and resolves them in one fell swoop." Additionally, several new instruments like the recently launched James Webb Space Telescope may yield the information required to finally evaluate Hawking's well-known theory. Over 80% of the universe's mass is made up of dark matter, which has no direct interactions with light. It simply floats around, massively altering the gravitational pull of galaxies. It's alluring to speculate that these enigmatic phenomena could be caused by black holes. Since black holes are notoriously dark, a galaxy full of them might hypothetically account for all the observations of dark matter. Unfortunately, black holes only develop in the current universe after enormous stars die and collide under the force of their gravity. Therefore, creating black holes takes a lot of stars, which need a lot of ordinary matter. Calculations of the early cosmos, where the first hydrogen and helium originated, have taught scientists how much normal matter there is in the universe. Furthermore, the amount of normal matter required to produce all the detected dark matter is simply insufficient. Because of this, Stephen Hawking proposed in 1971 that black holes originated in the chaotic environment of the Big Bang's early stages. He had explained how pockets of matter may spontaneously attain the densities required to form black holes, populating the universe with them long before the first stars began to shine. He also claimed that dark matter might be created by these primordial black holes. Lisa in the James Webb Space Telescope will disclose new information about black holes. In their most recent study, Gunther Hasinger of the European Space Agency and Nico Cappelluti of the University of Miami investigated the hypothesis of primordial black holes to see how it can explain dark matter and possibly address other cosmological problems. By looking for the first stars, galaxies, and supermassive black holes in the cosmos, they discovered that primordial black holes may have had a significant impact on the creation of the universe, or SMBH. They said that their findings suggest that stars, galaxies, and SMBHs emerged and grew in the past cosmologically very swiftly, possibly too quickly to be explained by the mechanisms seen in the universe today. Our study shows that without introducing new particles or new physics, we can solve mysteries of modern cosmology, from the nature of dark matter itself to the origin of supermassive black holes, Cappelluti said in the statement. Although this is just a model, experts think it might be tested shortly. According to them, the James Webb Space Telescope was created primarily to provide answers regarding the creation of stars and galaxies. The Laser Interferometer Space Antenna, or LISA, in particular, is poised to reveal a great deal more about black holes, even primordial ones if they exist, in the coming generation of gravitational wave detectors. Together, the two observatories, according to astronomers, should provide scientists with enough data to piece together the history of the first stars and perhaps even the beginnings of dark matter. Will the James Webb Telescope ultimately support Stephen Hawking's idea of the multiverse? It's time to confirm one of Hawking's most fascinating predictions, the multiverse concept. Now that the JWST has been safely transported to its destination approximately 1 million miles from Earth, the theory is unique because it was the professor's last to be published. Just 10 days before his passing, the work he co-authored with Thomas Hertog, a physicist at the Catholic University of Leuven in Belgium, titled Smooth Exit from Eternal Inflation, was submitted for publication. According to the multiverse idea, our universe, with its hundreds of billions of galaxies and virtually innumerable stars, may not be the only one in the cosmos, which spans tens of billions of light years. Alternatively, they could be a completely distinct world, and then another and another, all situated far away from our own. This novel postulates the existence of an infinite number of universes, each with its own set of mechanics, stellar and galactic compositions, and perhaps even intelligent civilizations. In other words, our universe may be but a small portion of a much bigger, much wider collection of realities known as a multiverse. The presence of doppelgangers or replicas is implied by the multiverse, which makes it, as some people will say, creepier. According to the logic, if there are an infinity of universes, but a finite number of ways to arrange particles in an individual universe, then the same patterns are destined to be repeated eventually. That would imply that at some astronomical distance, a precise duplicate of you would be reading a copy of this post. Additionally, there would be an endless number of these precise events occurring simultaneously, since there would be an infinite number of worlds. Let us know what you think down in the comments section, and please give us a thumbs up by hitting the like button. Finally, don't forget to subscribe to our channel and turn on post notifications so you don't miss any updates from us. See you in the next video.